So we're going to be doing theoretical probability, and we're going to be calculating probability using counting techniques. So essentially using everything, all the other ways of counting. So recall that the probability of something happening is going to be the number of ways of it happening on the total number of ways, assuming that each outcome is equally likely. Okay. So, example 1. So 7 people are lining up for a photo. If they line up randomly, WITP, that's going to be what is the probability. So what is the probability? That Abby is on the far left. Okay, so 7 people are lining up for a photo. If they line up randomly, what is the probability that Abby is on the far left? And we need to figure out both of these things. Usually the easier one to figure out is going to be the NS. So for 7 people, the total number of ways that they could line up would be 7 factorial. So that's the NS. And then for the NA, what we have is we have our 1, 2, 3, 4, 5, 6, 7, but Abby is over here. And so there's 6 people lining up, so that's going to be 6 factorial. So putting that all together, we get that the probability of Abby being on the far left, which is A, which is what we're looking for. Not A because of Abby, A just because that's kind of the generic letter we're going to use here. A just means, it's like X for algebra or theta for angles. A is what we use for these things. It's going to be NA over NS, which is going to be 6 factorial over 7 factorial, which is 1 over 7. And if you're going to do it as a percentage, it would presumably be something else. So another group of 7 are going to line up. What is the probability? I'll put my favorite 2 people together. That Joshua and Mackenzie are standing together. Okay, so the number of total is still going to be 7 factorial, not very exciting. Now, the NA though, so we have the Joshua and Mackenzie with other people, or the Mackenzie and the Joshua. So it's Joshua, Mackenzie, and another 5 people, 2, 3, 4, 5, which means we have a total of 1, 2, 3, 4, 5, 6. So it's 6 factorial and 6 factorial, which means it's going to be 2 times 6 factorial. So the probability of getting what we want is going to be NA over NS, which is going to be 2 times 6 factorial over 7 factorial, which turns out to be 2 over 7. If you wanted to do it as a percentage, it would be 2 divided by 7, which would be 14.3%. If you want to do it as a decimal, not 14.3, it would be, that was the previous one. It would be 28.6, it's 2 sevenths. 28.6%, which would be 0.286. And either of these answers would work. So that's correct, and that's correct. And you just have to pick one of those. So we're going to have 7 people lining up randomly. Same thing. What is the probability that Josh and Mackenzie are not standing together? And I'm going to do this one in 2 different ways. So we're going to do this in 2 different ways. So we're going to have, so method 1, we're going to call this one method 1. So method 1 is that we're going to say, okay, the NS is still 7 factorial, nothing very exciting about that. For the NA, we want them to not be together. And then we're going to have to do, so what we're going to do is we're going to do a good equals total minus bad thing. So we know the total is 7 factorial. We know the bad ones are them standing together, and we know from before that them standing together is, there's 2 times 6 factorial ways of them standing together. Which means that the good is going to be, or the NA, so that's kind of work, the NA is going to be 7 factorial minus 2 times 6 factorial. So putting that together, the probability of getting what we want is going to be 7 factorial minus 2 times 6 factorial, all divided by 7 factorial, which is 71.4%. Or you could write it as 0.714. Okay, so that was the first way of doing it. Now we're going to have method 2. So for method 2, the NS is still going to be, actually we're not going to do an NS thing at all. We're going to use a different formula. We're going to do the one where the probability of getting what we want is 1 minus the probability of not getting what we want. And the probability of not getting what we want, so we don't want them standing together. And so the probability of that happening was 28.6%. Now, I did this kind of deliberately. Notice there are different units. That's in decimal, that's in percentage. So we're going to have to, so you could do it in one of 2 ways. You could either go 1 minus 0.286, or you could go 100% minus 28.6%. Either way, the answer is 0.714 or 71.4%.